Mayank.
Today, how's the condition of internet connection over there in Bangalore?
It's working fine.
Both the connections, Airtel as well as Indira. So, Gautam Mani is in office. Gautam, Kuljor, Yash Gupta, Yogesh Sharma, Nirala Kumar. Anyone in office over there at Bangalore can acknowledge this. Are these people in office?
Yes, sir, we are in the office and the internet is working fine.
Yes. So, Gautam is here in office. Gautam as well as Yogesh, Yash, Kuljor. I think you are speaking on mute.
Ish. Ish is not here. Yeah. Even Kuljot is yet to reach to office. Yogesh is missing, right? Yeah. Yogesh
Yes,
is not
as
here
well
in
as
the call.
Gautam.
Yogesh
Gautam
is
is
on the
here.
leave, I guess.
Gautam is there in the office. Gautam Mani.
Yo, Kuljot is not here.
I'm talking of Gautam. Gautam Mani.
Gautam, yeah, he's also in offline. Let me check, sir. I'll just call him. Yash will be joining in 5 minutes. Yes. Let me check with Gautam first.
So till then, should we start? Guys, start with the previous task given to you. You people have done task. Here is Anish. He has a team. Anish.
Yes, sir. Good morning.
Yes, Anish. How is the task?
Yes, sir. Installation and the binding and curl process has been done.
Okay. Good.
Uh, we have to just configure with the HTTP team.
Okay. So can you briefly walk me through what steps you had to while doing the task itself?
Yes, sir. We have used the Ubuntu server,
Okay.
in which we have used apt sudo apt install as a proxy.
Your audio is a bit low. Please speak.
Yes, sir. We have used sudo apt as a proxy.
Okay.
Yes, sir.
Yes.
And for the
So you have
configuration,
installed as a proxy on Ubuntu Linux itself.
yeah,
Okay. So all the team members who are being told, apart from the team of web server, on the previous task, they had to install the HA proxy onto their VMs. So all had completed that task,
Yes, sir. Installation part has been done.
has been done by all the people in. Okay.
Yes, sir.
So you people have got some challenges in installation also like that, or it was a smooth layout, the installation part.
It was smooth, sir.
So basically, you use the repository, apt repository. You just had
We have
put can you again repeat?
We have used first method.
Okay, the first method using app, that the simplest one basically.
Yes, sir.
Okay, so after the installation of HA proxy, had you configured the HA proxy with target as well as listener?
We have not configured with the HTTP team, but we have tried with our own Windows.
On. So can you show me your, can you present your screen itself over here so that you can have a look?
My screen is visible, sir.
Yes, your screen is visible.
So over here we have used the HA proxy.
Yes. So here's a configuration file where you have done some sort of
APG files.
okay.
And we have downloaded the sudo apt install HA proxy.
Okay,
Yeah.
done. So after installation of HA proxy,
Yeah, so
where
configured
what is the
this.
configuration? Yes. Yes. Just show me this. Okay. So what basically you had done is this front end is 10.0.2.15. What is the IP address of the VM what you are using for HA proxy? Or where you had installed the HA proxy? What is the IP address of that VM? This
It's
particular VM.
configured. Yes, sir.
Manish, your audio is bit very low. Have the mic in front.
Yes, sir.
Yes.
It's configured with the wrong IP address. Like
Wrong IP
you can
address.
see.
Okay. What is the IP address of this machine? Is it is the IP address IPv4. Hmm. It's automatic only. So just to all of you, a thumb rule while configuring the servers, which should be used in configuration of clusters, your IP address, private IP address must fall in static category until and unless there is a particular use case to use the dynamic addressing scheme. Because the reason is, consider we will be having dynamic address allocation, we can always get the different IP address upon boot up or address table full state. So in that condition, if we had configured the particular IP address on other applications, so that link will fail after the IP address of the VM will change. So as a thumb rule, every engineer must know that while configuring the VMs or servers itself, first thing to check is do the networking properly of the VM. And in proper networking, you must be giving the static IP addresses to the machines. So in this case also, you must have given the static IP address to the VM so that no sort of problem can happen in future. Okay. So you understood, Anish?
Yes, sir.
First, after installation itself, the step you need to take is change the IP address of the VM whoever is hosting the server to a static IP address, and that static IP address must be falling within the subnet of Office network. To check the subnet of Office network, just for the first time, get the IP address dynamic way, and if it is allocated, and change that particular dynamic IP address to static IP only. Because in that case, you will be well assured that the same IP address is not being used by any other machine or pooled machine itself. Unique should be there to avoid the collisions and all conflicts itself in the network. So this is the
Yes, sir.
first case. After configuration of the static IP address into the server machine or VM, you need to then configure the load balancer. Configuration then starts from there. You need to put the static IP address of your VM itself for sure is hosting the server as a listener, along with the port number of your choice. And in web servers, 80 is the default port number. So can you just show me again your screen and show me the configuration file, CFG of HA proxy? I can give you a brief idea. The configuration file, yes. See, over here where it is written front end, my front end, the fifth last line, bind to 10 dot something dot something. There you need to give the IP address, static IP address of this VM only. So it is hosting the HA proxy server. Okay, load balancer. And again, after bind, you need to give the port number over it used to listen. You must
Yes,
be
sir.
following the document itself. After that, in backend servers, you need to give the IP addresses, the static IP addresses of the web
Listen.
servers of the machines, not listeners, the target. Backend is target.
Yes, sir.
Of all the machines whatsoever are hosting the web servers. That was the part I told you in the previous session only that web server team need not to fiddle on with anything because we will be using their servers over as targets over here. You need to give the IP static IP address of that particular VM hosting the web server along with the port number on which it is listening. And the port number for web servers is normally by default 80. So it should be like
Yes, sir.
something something colon 80. And we can use multiple number of servers as web servers, like a target group, because backend server is a target group. We can have 10, 20, or any number. Like if our team was of 4 or 5 members having web servers, we can always get the 5 server 1, something, server 2, something else, server 3, something else, server 4. So it will be using round robin by default to load the traffic, to balance the traffic into these and target servers in a contiguous fashion. Okay, this was all the purpose of the drill. Anybody else has done such sort of thing? What I told? Any configuration done by any other team member on their HTTP proxy on the HA proxy? Anybody, or should I target or choose myself? Uh, Japneet, have you done the installation of HA proxy?
Yes, sir. Once I had done the FTP server thing, so I tried doing the
Mhm.
HA proxy one, but then the VM is crashing again and again. I could share my screen if you want.
Yeah, just share it out.
Just a minute, sir. Just a minute, sir. Is it visible?
Yes, it is visible.
So this is a problem right here. The cursor is not
What
visible to
exactly is
me.
the problem?
Sir,
We
actually,
are just
the machine is
getting
hanging again and again.
logging. Acha, it is hanging. So
Yes, sir.
must be hardware constraint from your
Sir, actually,
your
I've written the required amount of commands, like I've written the syntax and everything. I could share the screenshots in the chat section as well once it opens up.
okay. Just send the screenshots afterwards.
Okay.
Fine.
Sir, I'll have to restart the system now.
Okay. So is Muhammad Sameer available over here? Muhammad Sameer.
Yes, sir. Yes, sir.
Just have you got the installation of HA proxy successfully?
Sir, I am in web server group, so I am on system.
Okay, you are in web service. So Deepak Kukreja. Yeah.
Oh, yes, sir. Yes,
Yes,
sir, I
Deepak.
have done the installation part.
You are done with the. Can you people put your webcam on? Okay. So you had done the configuration also?
Yes. Yeah, I have tried configuration. But
Can you just present your screen over here? Yes, Deepak. So okay. Can you show me the
sir, I have
terminal of the
applied
work?
these steps.
Yeah, that is
Right, sir?
fine. Can you show me the terminal of the virtual machine where you have installed the HA proxy?
Sir, I was stuck in this part. Girl, this one.
No, you had done the app install HA proxy part is completed.
Yeah.
So you are stuck at what part?
Mm, This part. Girl.
So you are writing 10.0.2.15 over there.
No, it's a IP, right?
Yes, it is IP, but why refresh? You had configured the HA proxy configuration file. Now, just show me the configuration file of HA proxy.
Okay.
Can you go a bit down to the file? Scroll down the file itself. You need to use arrow keys over here because this is terminal. In your configuration file itself, I want to see, yes, what are the, so where you have given the front end as well as back end. So curl will only work after you will configure the front end as well as back end. So you need to route the traffic to some server itself. Now, in that case, you will be curling to the load balancer's IP address, which in this case is the IP address of the VM over which HA proxy is installed. And before that, you need to configure this particular file with the front end as the same IP address of static IP address of this VM only, where you have installed HA proxy along with the port number, and the backend should be like the IP address of the web server, which is in it should be in target group, like over where the traffic will needs to be routed. Understood?
Okay, sir. Okay.
So
Okay.
before you have completed all these steps, the curl command will not work. Logically, it should not work because it don't know that where to route the traffic to, and actually HA proxy is not working because it don't know in the configuration, because in configuration file only we give the information to the load balancer that what is the listener and over where we want to route the traffic to. We want to distribute the traffic to or balance the traffic onto. What is the target group? Now you understood?
Okay, sir. I will. Yeah, I will try it again.
While reading the stuff or document itself, just make a habit of understanding what the different steps are. The actual thing is basically first you need to understand the concept of the technology. Here in this case, HA proxy is a load balancer, and as I had told you in the previous session itself, how HA proxy works. What are the listeners? What are the targets? So afterwards, I had also given you brief about what configuration files are and how those things are crucial in configuration of the load balancer. And then afterwards, you can always route the traffic. This is a test step only. Curl is a testing step that whether all the things are working in perfect fashion or not. Okay.
Okay, sir.
Get the things. Okay. So people if just make a habit of getting the documentation or grabbing the documentation in the right fashion. That is very crucial for you. Okay. So this 30 minutes passed, and now let us start with the session now. So yesterday was no class, and is supposed to be, has been visible to you all. So yesterday itself, I told you that I given you two links. One for actually what application load balancer is, and another one is what basically target groups are, and uh, how we can simplify the deployments using weighted target group. You people have gone through those documents, those
Yes, sir.
what any challenges in understanding of those things, concepts? Anyone? What are the things? What actually application load balancers are? What its usage is? What listeners are? What targets are? Or should we recapitulate those things? To give you very brief of what application load balancer is, it is just like network load balancer or Redshift proxy, which is having a listener on one side, and afterwards, what that listener does is to uh, targets. And that particular targets are inside something what we call target group. And in application load balancer, we can always have more than one listener. Have multiple target group. So, what is the basic difference between application load balancer and network load balancer is it works on IP addresses, which is layer 3 of OSI model. So network load balancer only understands IP addresses. Yes. So in network load balancer, the listener should be some IP address, which is the IP address of the VM or server hosting the load balancer itself. Okay. Okay. Yes. Along with the port number, and targets will also be the IP addresses of the target machines, may it be web server or any other server where we want to distribute the traffic onto. But in case of application load balancer, the listeners are URLs, URIs, right? www.translab.io/carriers. This particular section, may it be carrier is hosting some sort of web application also. So this will be the listeners. This will be the listener for the application load balancer. Okay. So in application load balancer, a single application load balancer can host multiple listeners. So let us take an example, www.translab.io/carriers, which is hosting some sort of web application on the website, must be one listener Another one should be www.slab.io/business. It is second listener, which must also be hosting any other microservice or second web application actually responsible for business purposes also. This will be responsible for human resources also. HR web app, second is web app for marketing. So in this particular use case, Translab.io is a single domain itself, and it will be using a single load balancer. Like here, the load balancer will be single one. Okay. We need to create rules over here in listeners, and rules will be depicting what URIs needs to be used as listeners. So in this case, actually what happens will be the traffic from DNS, or in AWS environment route 53, because DNS uses port number 53. That is why nomenclature like route 53 came into existence to routes. So those particular services are being used to basically direct the traffic from any domain. May it be translab.io or anything. The traffic hitting onto the translab.io domain will actually be having the A records. A record means IPv4 address relating to URL. So that IPv4 address will be of ALB, application load balancer. So what Route 53 will be doing? All the traffic coming onto the domain translab.io will be translated to, or will be transferred to, the IPv4 address of load balancer. So all the traffic will be coming onto this. Now, when this load balancer will get the incoming traffic stream, then it works on ALB, works on layer level, means application layer. So it can understand what are the URIs. So like translab.io / something. So what is in front of / as per that, it can always get the traffic diverted to what listener? May it be listener number 1 or 2. If listener number 1 listens to carriers / carrier, it will give the traffic of / carriers to listener number 1, and will give the traffic of / business, I told you there, to the listener number 2. These all depends upon what rules we have defined in the load balancer. Load. Okay. Got the point. Now, inside that, there will be some sort of similar fashion, whatsoever we had read in network load balancer. The front end will be now this URI, and targets will be of different kinds. Targets can be in AWS environment, can be some instance ID. May it be ID of EC2, over where actually the web server is present. Instance ID can be target some Lambda functions if we are using serverless. Lambda function can be the target, and afterwards we can always have IP addresses as target. But the IP address in this case should be private. No public IP address is routable over the internet on application load balancer. So that will be creating conflict. So it is specific that private IP addresses can be used as targets. In the similar fashion, target can be anything. IP address private or lambda function, whatsoever we have configured over there in environment, AWS environment, to host the web application also. Because lambda function is serverless, they can host. The third one is we can always have instance ID, like ID of EC2, whatsoever is hosting for AWS environment. This I am specifically talking of AWS environment. Okay, in this fashion, the traffic can be balanced onto the various targets. So now, what is the concept of weighted target groups? So what weighted target groups are? We can always have a single listener, and to the single listener we can have multiple target groups assigned. So in this case, we can always have listener 1, to which we can have PG1 having target. Let us suppose 3 targets. And other should be PG2, target group 2 with 2 targets. Let us say 2 or 3 whatsoever. So what is the purpose of weighted target groups? Or what actually weighted target groups are? So we can always in application load balancers have a terminology that a single listener can redirect to the traffic to the 2 different target groups having multiple target machines inside them. And the reason behind using weighted target group and that they can be weighted itself. Weighted target group means if I am getting 100 requests on this ALB, 100 concurrent requests on it. So if we'll be using weighted target group, we configured it like that target group number 1 should have weight of 80 and target group number 2 should have weight of 20. This means 80% traffic will be routed to target group number 1 and just 20% of traffic will be routed to target group number 2. Means if we are getting 100 concurrent requests, so 80 requests will be going to target group number 1 and 20 requests will be going to target group number 2. Understood? What's the concept here? Anyone present over there can acknowledge you are getting the point. Got it?
Yes, sir. Yes, sir.
Okay. Now the point over here is what is the need of, because if I'll be using a single target group and we'll be load balancing the traffic between 3 of these, then always we can use round robin for having 33% on each. We can be using others like that. But what is the need of weighted target groups over here? And each target group will be having different set of targets. So this is just for a condition wherein businesses, if I am having a application stack hosted on, let us say, EC2 instances. In one case, a application stack will be hosted on EC2 instances and then that application is being served. Okay, let us take an example over here. All the 3 are EC2 machines. So having similar applications scaled out so that all can give a single sort of result, a similar sort of result to the users, and the traffic can be load balanced. Okay. Now let us take an example that particular organization who is developing this application wants to modernize the application. Now they want to modernize app. So they are going from the monolithic mono architecture to microservices architecture. So Now they have created another web application stack itself, which is totally different from the previous EC2 application stack. And though that application stack is being hosted on, let us take an example, Kubernetes platform, or that is containerized. Now the application is totally overhauled and is being hosted on some sort of containers structures. And parallelly, they want to test in production environment that how the containerized application is behaving. So for the actual testing, not just beta testing, for the actual production environment testing itself. So what they'll be doing, and if they also for having the redundancy or the application itself, if maybe is some sort of banking application or so, they don't want to break the whole system on a single time. So what they'll be doing is they'll be having different target groups. One target group will be hosting the previous architecture, which is tried and tested and was working flawlessly. And they'll be giving weight of 80% to that target group. And the new architecture, what's made to be K8s, Kubernetes architecture, they have created will be put onto some another target group which is having a less weight, maybe 20 only, just for testing. So what they'll achieve over here is for every 100 requests, 80 requests will be going flawlessly, 80%, you can say the 80% of throughput is basically guaranteed because that particular application stack is tried and tested. And what other 20% requests are going forward to will be of testing environment. So it can always work 100% flawlessly. It can always work 50%. It can always do something. So in this case, total application will not break. Whole of the application will not go down at any single point in time. So this is what we call blue-green deployment strategy. Blue-green deployment strategy. So over where we can have concurrency. Just write these things onto your notepad or anything, anywhere, because after this session, you need to write all these things into the chat box that what you have read today. So this is what we call blue-green strategy, where we have two different sort of stacks being used to different sort of stacks deployed for an application to be served over there. Now you people understood what this particular strategy is all about. Why weighted? So after, in the course of time, when they'll be testing this new strategy and they'll be getting confidence on that, they'll can always go to increase or change the weights. So after some time, they'll be giving 50-50 weightage. Means after they have successfully tested the thing, they'll be giving 50-50% of the weights. Means half of the commands traffic will go there, half. Then eventually what they'll do, they'll be increasing 90-10%. And at one point in time, they'll be giving 100% to this, 0%, and then we'll shut down this target group. And the whole traffic of continuous testing will be going to the second target group. This is how, in a proper fashion, the deployments or new stacks are being introduced. Understood? The concept itself?
Yes, sir.
Okay.
Yes, sir.
So this was all about what need to be covered is blue-green strategy, what are the application load balancers, what are the weighted target groups. Now, what we need to cover is what we okay. I had given you a brief about what we will be covering today itself, and the thing was the concept of containerization. You know, any of you people know the term containers? What containers are? Anyone?
So they are forms of VMs only, but actually
Yeah,
differ in their
so
operational character.
not exactly we can call them VMs because they are having a bit different architecture from VM. Basically, VMs are heavy enough, they'll be having a full operating system stack in it, full kernel level things in it. So containers are a bit different. But
So like
you,
VMs are limited to a single OS,
yes,
which can run on a VM. So to
mhm,
run multiple instances of an application in a single host machine, we can use containers as like they provide a virtual environment in a single machine. So for
sandbox sort of environment which are different
sure,
from
yes
each
sir,
other.
yes sir.
And we can have running different sort of applications or application stacks onto a single VM in different isolated containers itself, like that.
Yes sir.
Okay, that is also fine.
And
Anyone
and
other
when
from? Yes, yes.
in when we talk in the terms of Azure, as far as I know, whenever we
Mhm,
create a container, we have
mhm.
to choose this option called connect container registry, where we choose the OS before itself. So it will be a very different virtual machine. In virtual machine, we'll choose whatever operating systems we want later also. But in
Mhm.
container, if you want to deploy something, it is already fixed within the container registry. That's how it is.
Okay. So anyone had used Docker itself before or had created some sort of Docker images so that that particular Docker image then can be deployed onto a container or can be transformed into a container sort of thing? Had worked with Docker images also?
No sir.
No? Wait a second, I'm getting a call. So sorry for the interruption. So what we are talking of over here is containers. So containers are different from VMs. No, what we want to understand over here is, as already I have given you a brief, that what is concept of containerization? You people are going good on the lines that you know what basically containers are. They are to have the sandbox environment within a single VM or machine so that multiple of the application stacks or the different in may be non-dependent applications can run on a single virtual machine or single uh, environment itself without having any you can say interference with others. So that is one of the point that we can have multiple containers spin up upon a single host guest operating system on a VM. Okay. Another thing is what is the history of containers? Why containers comes into picture? Reason. Any of you know what is the reason of containers being introduced into this industry, or what is the importance of containers? What basically in any industry, if there we feel some sort of need or we get some pain from something, to heal that pain itself, we introduce new technologies or concepts. So what was the pain before the containers comes into this? What pain points containers healed of the enterprise or industry, and they become the standards. So they are adapted, they are accepted worldwide. over the industries over virtualization. That is why container technologies are growing leaps and bounds. You know what were the pain points the containers rubbed? Anyone? Any one of you?
Sir, actually, the containers are lightweight and portable, and they make easy to deploy and develop the applications across the different computation environments. That's why they are
Yes,
so.
that is fine. And what this lightweight sort of thing, now you can hear me on the Teams call
One second.
because I'm
Can you
on.
hear me?
You people are heard of because you are
Now we can
talking.
hear
I
you.
believe Krishnaveni and I am getting Mayank is talking. I am getting.
So now we are getting off this.
Audible, sir.
No, no, I am audible.
Yes, sir, you are audible.
To all anyone who's left out, who's not getting my voice properly. No, so will. Again, I'll be giving a brief about what container is because most of you have told the concept in a right fashion, and someone from you has told that container is a lightweight sort of thing. So that will be beneficial. It can spin up in least possible time. It can start the application serving within least possible time. Like in VM environment, to boot the VM itself, it takes a huge amount of time. And why containers comes into picture is the issue of scalability. When the application stacks became large enough and they need to serve the millions and billions of concurrent requests at the same amount of time. So those huge application needs to have a provision or a sort of architecture so that they can always scale in and scale out in a dynamic fashion. What scale in and scale out means is to increase the number of application instances serving the customers or clients, or to decrease the number of instances serving the client. Number of instances means the singleton application serving unit. So let us take a very brief of this over here. See, what previously was, we can start with an analogy of, I believe you people are very young itself. Let us take my own example. I passed out class matriculation or class 10th in year 2001. I done my 12th or senior secondary in 2003. Completed my engineering in 2007. And what difference came over here in these years is whensoever the result or board result came out, on the day when result was out, normally for 10th class, the result was out on internet. We used to go to cyber cafes at that point in time. And what we found over there is always result website now. We people for getting just a result sheet of us need to wait over for 2 hours or 3 hours here at cyber cafe And every time we press the website URL, it will be giving 404 error. Website not found. So day before that, the day before result is declared, or it just few minutes before result declared, the website was fine, was basically working flawlessly. But at the point in time when the news break off that result of class 10th is declared, the website goes down. What the purpose? What is the reason behind that? Can anyone of you quantify this problem and explain that what should have happened in that? Yeah.
Due to a lot of traffic on the application.
Because we was
Yes.
not
Yes.
able to, would basically the site was not able to scale up.
Yes. Traffic.
The server at which it would have been uploaded would have
Mhm.
crashed and was unable to take the load of the amount of data that got.
Perfect. So in 2001 and 2003, similar things happened. So reason was in 2001 there was no virtualization technology. Virtualization comes after this era. What virtualization is? VMs were not very prominent. People were not aware of the concept of virtual machines or so. So what they were using to host the servers, to host the web server containing website, what I can say, result website, and a database of result, they need to rely upon power servers, which were physical in nature. So what they will be doing, they need to have a 64 GB machine, 64 GB RAM hardware along with some Xenon processor, a tower sort of server they'll procure, may it be JNK Board of Skill Education, may it be any other CBSE or so. They need to procure such sort of servers. They need to put the web server, may it be HTTPD or Apache Tomcat or anything. They need to install that thing on over that server. They need to put the website data onto that server. Then they need to configure that for traffic. What was case over there? Because this particular server is just 64 GB RAM and may it be 24 core Xenon processor. So it will only be able to cater, let us take an example, 20,000 requests per second. So that will be the case at that point in time. So at any normal point in time on any day, which is not result day, they expect less than this traffic only. Less than, because nobody will be going to the school education department's website unnecessarily. Just for any sort of documentation purpose. So no more than 20,000 requests. So that particular hardware will serve the best for all the 360 days. For just 3-4 days itself, when results will be out, the traffic will surge up to, let us take an example, CBSE or JNK Board of School Education is having, in 10th class only, okay. The thing is, as what I was discussing, that normally in any point in time, 20,000 requests will be enough. Now, in this case, for the result days, traffic may surge up to, let us take an example, 10 lakh requests. All right, we can say 10 lakh total number of people. So for you can say per second, it may or for hour or so. Let us take an example. It will surge up to 1 lakh concurrent requests. So what will happen? This single server will not be able to serve the actual concurrent 1 lakh requests, which was designed to be served only 20,000 requests. So what will happen? 1 lakh requests will come over to the server. It will get in deadlock condition. It will be get overflowed with requests. It will take this particular thing as DDoS attack and will stop serving 404 error. So to curb this problem, what we need is we need 5 servers with same stack working concurrently. We need 5 of the servers working concurrently with similar application stack so that each can individually serve 20,000 requests. And we what need over that is a load balancer what can transfer or balance the traffic onto these 5 machines so that all the 1 lakh requests can be scattered in a contiguous fashion. Okay, understood. Now, what we call this terminology as in computers industry, we call this that we have scaled the application stack to the scale of 5. Means we have scaled the stack to the scale of 5. Means multiple of 5. 5 times we have scaled the application stack. So in that particular point in time, when virtual machines were not there, all these things were handled on physical servers. It needed a lot of manpower, man resources to actually first install the operating systems on the bare metal servers, to first assemble the bare metal servers with the required infrastructure like RAM and all. Afterwards, the operating system need to be first hardware part needs to be taken care of. Then we need to install operating system. Then we need to install dependencies for the may it be HTTP server, may it be like Java or so any of it. Afterwards, what we need to install server, may it be HTTPD or so. Then what we need to put data of website on server. Then what we need to do is configure networking of server. Configuration of networking server means to give them static IP, to open ports, to give firewall rules and all. So these are various steps what needs to be performed on each physical server to get a scale of the previous application itself. So it is a tedious task. It consumes time. Apart from that, we need to configure load balancer again also. Configuration of load balancers, creation of load balancers. So at that point in time, this particular task for scaling of things need weeks of time. And after that, we need to test also. Testing will also be part and parcel of, because we will be configuring all these things manually. And if we are going in a manual manner itself, human errors are prominent. Humans can always give different or bad commands. If the process is not automated and is being handled by humans itself, then probability of getting the errors or the issues goes high. So also testing them will be some sort of, it will take some quantifiable amount of time. So what I am saying, at that point in time, it takes normally weeks for just scaling out the hardware system, or just scaling out the hardware system so that the application can be served for larger amount of traffic. It takes weeks of time. And if we will be employing engineers for weeks, we need to pay them salary for just a simple task of scaling. We need to pay salary, man hours to those resources or engineers. So it will be, that process was time consuming. That process was costly to do. So that is why those points in time, normally the organizations like education department were least bothered about the problems being faced by students. On result is they normally go with the flow only. So we were getting some sort of 404 errors and traffic down. Afterwards, some virtualization technologies comes into picture. Virtualization technologies was led by VMware. People have heard of this company, VMware. They have created some sort of type 1 hypervisors. So their flagship is ESXi. ESXi is a type 1 hypervisor being created by VMware. VMware is the name of an organization. You people have heard of this company?
Yes, sir. The workstation we use.
Yes. So basically, that company has leaded the virtualization phase also. When the virtualization comes into picture, what changed was that we were having rack servers. Rack servers were big enough with huge amount of RAM and processing power. May it be, we normally have some of the biggest racks will have TBs of RAMs in them, the scale of terabytes. So normal rack servers have normally 394 GB of RAM also. So this is the scale how that hardware is being made in this sense. And processing all rack servers were having multiple processors, multiple physical processors with 48 cores or with 96 cores or so. So huge amount of processing power and random access memory was available with rack servers and all. So what VMware has done is it has installed some sort of hypervisor directly on server, bare metal servers. So what they do, they created the VMs as per the user's requirement on those rack servers, and will have quantifiable amount of RAM as well as the processing power left with that. So at the time, if that particular VM is hosting some sort of web server application, and at point in time, if we want to scale the web application itself, what we need is we will be creating the template of VM, having web server installed. So what is meant by template? Any one of you can give a brief of what template is? Heard of the term template? Heard
Yeah,
of the
sir.
term AMI? Yes, yes.
Yeah, I think it's a pre-written code that you don't have to write again and again. You just use a pre-built code and build on that.
Basically, template is what? Normally, what we do from scratch in VMware's environment is, let me present you with the screen of mine, that I can give you a brief of how it looks like. Any one of you have gone through the VMware's Type 1 hypervisor, had a hands-on on that? Got to know about what? Had you ever worked with ESXi, Type 1 hypervisor
No, sir.
on rack server?
No, sir. No,
No.
sir.
Let me walk. My screen is visible or not? Other screen, the laptop.
No, sir.
Now it is visible.
Yes, sir.
This is basically how a Type 1 hypervisor looks like. People able to view?
Yes, sir. It's visible.
So this is basically the console itself of hypervisor. We have in our Jammu lab server, we have 5 of the Type 1 hypervisors installed over at 5 rack servers. Each rack server is having different type of address from 81 to 85. We have 5. This is the console of VMware ESXi Type 1 hypervisor. It is showing how much processing power is available, how much RAM is available, how much storage is available, what is going on. Afterwards, we have created number of VMs over here. Each VM is being provisioned with sort of random access memory. Various CPU parameters are being given over there. How to create VMs? This is also a way how we can VMs over here. We have hosted jump servers for network. You can say bridge. We can have the traffic from internet over to our lab by using jump server. That is a different concept also. We will be talking of that afterwards. So what I was talking about is that let us take an example. If I have created a VM named Rajiv or Nami or anything, and I have installed some web server onto that particular VM, this point in time, we have different IP addresses located to this VM. Let us take an example. I have a web server installed over here in that VM. This is Ubuntu VM. Let us take an example. I have web server installed over there here. And now what I want is I have another HA proxy or load balancer installed over there at maybe Shreya VM. So the IP address of Shreya VM will be acting as a singleton load balancer IP. At any point in time, all the traffic whatsoever needs to come to the web server will first be pointing on to this 192.168.29.148, which is the IP address of this load balancer, we can say. And in this load balancer, we have configured like that listener is 148 and the target is Rajiv. Target will be like 109. So virtually what will be going on, that all the traffic what needs to be served by the Rajiv web server will first come onto the Shreya VM's IP address. It will then load balance it onto the single, because in target itself, target group, there is only a single VM web server. So it all the 100% traffic will be going to the Rajiv VM. which is hosting web server, and in turn, it will be giving the results or the whatsoever request will be served by the Rajiv. Now, at any odd point in time or odd day, I want this Rajiv VM to be scaled to the factor of 5 to serve more concurrent requests. What I need is, first I'll be creating an template of this VM. Template of VM means the VM along with operating system and all the dependencies installed, also whatsoever the data is being inside that VM, may it be the website data or all, that will be packaged into a single file, which is like a package file, what we always say of ISO or so. And that particular package file then can be used to create some sort of virtual machine. Like when I clicked over here to create a new VM, what it is asking me of, create a new virtual machine. New virtual machine, I need to install operating system. I need to install all the dependencies from the scratch itself. So it is also giving a new option to me, which is deploying a virtual machine from OVF or OVA files. OVF or OVA file is what we call it. We can always create a OVF or OVA file from this particular running machine VM. So what it will be doing is, it will be just packaging all the information inside the OVA or OVF file, which can then be replicated onto a new VM. So in this fashion, in autonomous way, I can scale out the application. I can have 5 number of web servers spinning at same point in time without wasting much of my time, without wasting much of my energy. And afterwards, what I need to configure, I need to configure all the 4 other VMs IP addresses as a targets to the target group in load balancer. Then what it will be doing, all the traffic coming onto this particular load balancer area will then be bifurcated or load balanced onto 5 VMs in a round robin fashion, and the purpose will be solved. Now, what previously took weeks is taking days time only. Like, we have reduced the manpower. What previously took weeks to configure, now it only takes a bit of day or so to configure. And we can always cut down onto the testing part, because most of the things are going in autonomous fashion or in automated fashion. Now you understood how virtualization has changed or fast-paced the things. Understood? Any one of you? What the basic?
Yes.
Okay, sir. Now, again, there is a problem. This particular way of virtualization goes flawlessly. Right now, it is also going in a flawless manner because it is industry adapted standard, and we are using this sort of servers virtualization technologies for hosting most of our application workloads on VM environments only. We are using it for the monolithic applications and some sort of bigger applications. What needs to be served to the clients, we are going in this fashion. After some time, when we'll be getting the time, I'll be explaining you how networking in virtualization environment works. Like what I told you of virtual switch, this is how virtual switches work. This is what the management ports are. This is how kernels of the hypervisor are being consumed. These are the various virtual machines what are being connected to virtual switch, so that the networking part will be flawless in virtualization. This is not very time to cover these things. We'll be doing this afterwards. But now the point over here is that we got an idea that how the workload, what needs to be completed in weeks time, can be completed in a day time only, single day only, by using the technology shift. So this yields a pain point. So organizations need to shell out more money to the manpower for doing some tasks. Now those, they are basically reducing the costs. They are reducing the time consumption. So that is why virtualization was being adapted by the industry in a very hands-on manner. Now it works very smoothly for larger applications, for monolithic applications to scale. But when comes the era of microservices, the single application was split up upon into thousands of microservices at a point in time. So bigger applications whatsoever are being used or consumed right now are microservices based applications. And in that particular scenario, a single application is split up upon in the various or thousands of microservices. Let me explain that concept in a. Okay. So here, what we will be discussing of is what is the difference between monolithic and microservices based applications, so that you can get the understanding of why containers comes into it. What's the reason behind the containers as an industry standard. Likewise, we had talked of the bare metal servers in 2000 era, and then came the virtualization technology, how it yields the pain points. Now, what's the need of containers? As I told you earlier, that when microservices came into picture, we need to host thousands of microservices per application on a single application stack. So to do that, you can say scaling of thousands of microservices for a single application, we then need to deal with, may it be, if we want a scale of 5 to each microservice, then we need to deal with 5,000 concurrent application instances, smaller application instances to be deployed on VM. So to deploy or to create a scale of templates for single monolithic application, it is easy. Like I want to scale a single monolithic application into 5 instances, I can always go in manual way and create a scale of 5 for that particular monolithic. But when an application having 1,000 microservice instances needs to be scaled up on a VM environment, so each VM will be catering only a single microservice. So we need thousands of VMs for serving a single application having 1,000 microservices. Understood? We need enormous amount of virtual machines because each microservice is independent of each other. It can operate from different guest operating system also. So that was the reason that to scale that application to the factor of 5, we want to scale 5,000 instances. So that is not, that is very troublesome or can't be done by in a manual manner. So what we need is, we need a platform over where multiple amount of microservices can be spun up upon single VM. Whereas in the initial phases, someone was saying that containers can be spun up upon a single VM. Like we can spin up hundreds of containers on a single VM, provided the VM will have the enormous amount of computing power and processing power. Because all the containers will be segregated or are in a sandbox environment, non-interactive with others. So this is why containers comes in. To host microservice. Likewise, here coming on to monolithic application, as you all know, is a single large application what have a database but have a classical three-tier architecture, means data access layer, business layer, presentation layer. Presentation layer is nothing but front end, what we can say business is middleware, and data access is what we can say back end. Front end, back end, and middleware. And then browser normally requests something to the front end. Front end in turn talks with the business layer. Then business layer in turn get the data from data access layer. And the whole the thing is present in a single package. This is how monolithic applications work. Traditional applications were like that everything was integrated. Every functionality of that application was very tightly bound to every other functionality. Likewise, in this speaker system, everything is bound. We can't split the speakers out. We can't split the buttons out. We can't split the other things out of this radio transistor. But what if we want to have new functionality added without interfering with the previous functionalities in a application stack itself? Like in this case, we want a CD player and we want to reuse the speaker system from that particular previous radio transistor. It is not possible. In case of monolithic applications, we need to rewrite the application. Okay. But what if we change the whole thing? Like if we want different applications for different tasks, and in modular applications, speaker systems in this case are different. The CD player can be different. We can always use these speaker systems with this particular CD tray system or with cassette player system or with anything. So this is a modular approach also. Each part is independent. Okay. So in monolithic applications, what already we had discussed, there is a database, data access, object, business layer, and UI or node. Like here it is saying, if we have a single monolithic application and we want to scale that application, we need to replicate all the layers. Means we want to have node 1 with all the similar functionality, node 2, node 3, and actually load balancer is all being used to segregate the traffic. But in monolithic application, actually the features are very tightly bound to each other. So we can't even think of splitting up of that particular big monolithic application because the interdependencies are way more. So it will be easy to write the new application stack instead of splitting it up. So for every new feature, what needs to be incorporated on monoliths, it will be having such sort of structure that for everything we need to incorporate any other feature over and above to the other, which is a tedious and cumbersome. And to maintain the monolith, it will become impossible because the stack will grow complex enough after every functionality addition into the application. So normally the dependencies of monolithic application kills the developer. So what microservices are? Microservices are software components of the system that are independently releasable, independently scalable from other parts of the system. Independently scale. I already had told you the concept of scaling. Like we can have replicas of that. So each microservice can be scaled if the application 1 is having microservice 1, microservice 2, microservice 3. Let us take an example here. Application 1 is having 3 microservices. Each microservice can be scaled on his own. Maybe if I want just a scale of 2 for microservice 1, we can achieve. And if microservice 2 is way more critical and data intensive, or more of the requests are coming onto the photos section of Instagram, then and M2 is basically responsible for photos section of Instagram, then we can always scale the M2 to the scale of 5 or 3 or 4, independent of what is the scale of microservice 1. May it be just only, I can say, chat. If chat is functionality which is not used much, and if photos is functionality which is used more, then we can scale independently of it. And if M3 is, you can say, authentication, authorization, login, then we can always have, because everyone wants to log in, we can always scale it to the factor of 10. So this is independently scalable. And independently releasable also means if a team is working on microservice 3 only, developers team, it can change the functionality of microservice 3 without thinking of microservice 2. Maybe there are different teams. Developer team number 3 is responsible for microservice 3. Developers team number 2. Developers team number 1. And they'll be having different DevSecOps environment. So each will be different, independent of each other. They'll work like a separate application instance. What and the communication between microservices goes through API normally using REST API calls. So this is how actually microservices works. So for a bigger application itself, what I can say, we can have like Instagram or the bigger applications or Facebook can have thousands of microservices running single point in time. Each microservice responsible for different tasks. And we can scale all those thousands in independent manner. So if we think of the scenario where we want to release these applications or deploy these applications on virtual machine environment, then how can we do? How can we create thousands of VMs? Thousands of VMs for a single application stack manually. That will be cumbersome, tedious, and can be fault prone. Failures can happen in that case. And how we can create thousands of this? And each and every VM will be hosting his own operating system, and that will be heavy enough. So we need enormous amount of computation power also. So to deal with such problems, this is what my so basically to deal with such problems, the microservices to deal with the deployment of microservices, the concept of containers comes into the picture. Scalability, scale I had told you. Then Docker comes into it. To pack the application in smaller instances whatsoever can be released and can be consumed in a flawless manner. So Docker is nothing but a containerization for software. So what container means?
Sir, Docker is a tool, right?
Yes, Docker is a tool. We can
Okay.
create containers or Docker images using this tool itself. So when the picture of this containers comes into the frame itself, the Docker was the very initial organization what flag holded this technology shift. Docker is a tool, yes, which is responsible for creation of Docker images, what can be subsequently spun up upon the servers in the form of containers. There are various other technologies also, container D, this is an engine. Docker is nothing, Docker is having Docker engine, which is responsible for Docker is having API, which can grab the thing. So it is a complex tool itself. The main purpose of Docker is to an open platform for developers, system admins to build, ship, and run distributed applications. Sort of applications which can be used in distributed environment. So, how virtual machine looks like normally. In a VM, you always know that there is a bare metal server underneath over which we have some sort of let us take an example here is laptop hardware. It also acts as a bare metal server sort of thing. It has RAM, it has some sort of for sake of simplicity only. Over which we normally install what is host operating system. In all your laptops, you have host operating system. What host operating system? Any one of you? What host operating system you have on your laptops?
Windows 10.
Windows.
Yes, to be specific. You are using Windows 11 or 10?
11.
Host operating system is Windows 11. Over the Windows operating system, what you people have done is installed a hypervisor. In this case, you have installed VMware Player. Okay. People have installed VMware Player. Over
Yes, sir.
that hypervisor or VMware Player, you people can have multiple virtual machines. May it be VM1, VM2, VM3 spun up upon. This is the case.
Yes, sir.
Each VM will be having their own guest operating system. May one can be having Ubuntu, other can have Oracle Linux, third one can have RHEL. This is the case. On all the three independent VMs, no, all the VMs here are independent of each other. On consuming the resources of your laptop's hardware. So over those operating systems, you normally install the dependencies, libraries. When you install apt-get something, let us say here one says apt-get install Java, JVM. So this will install libraries and dependencies of Java. Here Python. You can always install libraries and dependencies of Python over onto other operating system. And third one, may we have Node.js. So we'll be having libraries and binaries of Node.js over onto the third VM. Over that, we can always deploy application. Like if I want to install jar file or application with Java dependency or var, we can always host that on JBoss on VM number 1. And if I want some Node.js based application, so I'll be app with JS, Node, front end, anything, maybe Spring or anything, over to let us say Tomcat, Apache Tomcat. So that will be working like into the VM number 3. Let us take an example. For Python, I want to install some data science project application. I can data science. You understood the terminology of VM over here?
Yes, sir.
How it is different from containers. Containers are of different architecture. How containers work is, I have laptop, which is for server also hardware. I have host operating system onto that. Let us take an example. For the host operating system, we have Windows installed. Okay. Over to that, you need to install Docker engine. In this particular Windows platform or so, what you need is you need to have Docker desktop installed. It will be having Docker engine by default in it. How many people have used Docker desktop anytime? Have heard of Docker Desktop? Heard of that? Just write it down in free time. If you will get the time itself, just go and install Docker Desktop onto your laptop. It's a bit heavy, but it will make you learn of very soon. Okay. So if you are not going to use this particular stack, like if you are not don't want to use Windows platform, because normally containers use most of the containers in industry use Linux as base image. Linux as base image means they use they need to spin up the application onto Linux environment only. So the containers will be Linux compatible itself. Okay. So to spin up the Linux containers, we need host with Linux capabilities, Linux kernel capabilities. Without having a host with Linux kernel capabilities, we can't grant the resources to the containers which want Linux to be spun upon as base image. So, in nutshell, containers base image takes the resources from the host operating system kernel. So, this is a thing what needs to be considered while spinning up upon the container. No doubt we can spin up the Linux containers on Docker Desktop over Windows 11 host. But for that, we want to have Linux environment enabled in the Windows. We can always have Linux environment enabled in Windows.
Yes, sir.
When we will be having such Linux environment enabled in Windows, then only we can spin the Linux containers over that Docker engine. Or that Docker engine, then we translating the request to the Linux environment or Linux kernel itself over the window. This is a bit complex also. In your case, what you can do is you can have a virtual machine spin up upon in the your VMware player only. Virtual machine having Linux operating system, then install the Docker engine onto that particular operating system, which is maybe Ubuntu also. Just have a Ubuntu VM, spin up, have the Docker engine onto that Linux Ubuntu operating system installed using apt-get. There is a very simple tutorial. I'll be sharing you the link of that particular tutorial so that you can be able to install the Docker engine onto your VMs itself. Then over that, over the Docker engine, what containers are? Containers are nothing but having a reference to base image. Base image, what takes the data or the things from host kernel. Over that, bins or libraries, the dependencies are being installed and just the application. So, like, in contrast to virtual machines, virtual machines have a full set of host operating, guest operating system installed. So they are heavy. They need to have all the things being installed. They are heavy. They are resource intensive. So, but in containers, we get all the kernel dependencies from the host operating system and the just dependencies like libraries as well as application will be those will be packaged inside a Docker image. So they are light, easy to spin, fast enough to start. Because for booting up a VM, whole set of operating system needs to be boot or spun up upon from the basic. But in case of containers, actually the kernel or the host operating system is already in working state over which Docker engine is relying upon. And just what we need to initialize is libraries, and applications. And that is a very small task. Like in a operating system of ours, just to start an application, the time needed to start an application is equal to time needed to spin up a container, because operating system being consumed will be of hosts. Now understood the difference between basic difference between container and virtual machine. So why means fast enough. Containers are faster than VM. Needs to be spun up on it. Benefits: we can always build, ship, and run any application as portable container that can run almost anywhere. Tested on a different servers. So dependency on the operating systems goes off. The application can be spun or scaled in a flawless manner. Multiple development environments can be run from same host. Different configurations like dev environment, UAT, testing environment, and production environment applications can be spun up upon a single VM with Docker. We'll be having different containers, we can test them out. Endless possibility. Collaboration in same settings. So settings will be basically configurations and settings will be packaged inside a container itself. So that will be automated process. More fault resilient process. So these are the ease of use, speed, fast enough. Docker Hub, I already had told you in the chat itself for Docker. It is nothing but a repository. Repo to save Docker images. Docker images are nothing but the a sort of package files to spin up a container, which can be converted into container on internet. Docker Hub is a repository to store or save Docker images created by you on the internet. Normally, you'll be having a Docker Hub account. Have you got, any one of you have got a Docker Hub account or a free Docker Hub account on the internet? Anyone? No. How many of you have GitHub account on the internet? Most of you have GitHub account? Yes, sir. Okay.
Yes, sir.
So you all are developers over here. Congratulations. So none of you have got a Docker Hub account. Just go onto the internet, search Docker Hub. There you will find a Docker Hub website. Create a free account over there. In the similar fashion, GitHub account is created. Free account of Docker Hub can be created. So that is mandatory for testing or hands-on on Docker images. So today I'll be giving a task to install Docker engine onto your Linux Ubuntu VMs. I'll be giving a document to you for that. And when you will be having that Docker engine installed, then tomorrow itself we will be learning that how to create Docker images, how to spin up the Docker images as containers onto the VMs, how to test the things out, how to deploy those things. And when you will be creating the Docker images, then you can always save those Docker images whatsoever will be created by you by writing the Docker files onto a repository on the internet, so that you can always use those images at any point in time on any other machine. Because you can always fetch your Docker images onto any other machine from the internet repository, what is known as Docker Hub. You just need to have an account over there. Okay, I'll show you how to upload the things or how to push the things onto the Docker. Likewise, on command line interface, Git commands work. Similar fashion, Docker commands also work onto the command line interface. Okay, I'll be walking you through all those things in tomorrow's session. Okay, after you will have the installation of Docker engine onto your VM. So modularity and scalability, easy to scale. What we had discussed already, how scaling can be achieved. So So VM versus Docker, size of virtual machine is very big, like an elephant. Size of Docker container is very small, like a rat. Startup. Docker virtual machines take a long time, like to start. Like Sonic, containers are flash. In a very small amount in time, they start up. Integration. To integrate the applications serving up upon from VM, it is difficult part. We need hell a lot of configuration changes, and that configuration changes on VMs is in manual fashion. Okay, those are in manual fashion only. But in Docker images or containers, all the configurations are being written in Docker files. We can consume those files and have the things configured in autonomous fashion. That will be integration will be very easy. What was the architecture? We already had discussed in previous slides. And what is the architecture of Docker? You understood this architecture? That is the base or reason why Docker containers or why containers are faster than VM. This is the main thing. Here we have guest operating system onto the VM, but on Docker engine, there is no guest operating system. We just will be using the kernel of host OS, which is already said. Okay. In one liner, if I will consider microservices are running inside containers or on top of. Now, what already I had told you that microservices is the basic reason why containers are so adapted. Because in a application with microservices stack, there are enormous amount of microservices or smaller services what are being spinning up. So for that reason, it will be difficult to handle the large amount of application microservices in a manual fashion. We need some sort of segregation. We can't even think of the creation of that much amount of virtual machines because it will be power hungry, very slow system. So for that reason, containers comes into picture. A single VM can host multiple containers over there. So that is why containers are on top of what is the spinning instance is called container. Inside a container, we will be having a micro service working with networking and all the things. Platform. Now, what platform? So there are multiple ways how we can deploy the applications onto microservices-based applications onto the may it be EC2 or in container environment only. So one is using Docker to manually start the containers, to manually create the Docker images, and to manually create the networking between the microservices. This is one way. And another one is to orchestrate all these things by using some sort of platforms. What can take care of scaling, high availability, fault tolerance, automation by itself. So it need not to have any sort of intervention or regular intervention from the users for deployment of microservices or for consumption of microservices. So what that platforms are, one is Kubernetes, what orchestrates the containers. Will do the things in autonomous fashion. We just need to give them a brief like manifests named YAML files, which are a set of codes which the Kubernetes platform will be consuming to orchestrate or deploy the larger or you can say complex applications based on microservices. So it will be getting the auto scaling. It will be getting the horizontal pod autoscalers working. So those or the very advanced concept. Will not be going into those concepts. So for very basics, Kubernetes is a platform. What is needed to spin up on the container? Okay, so we'll be going through the platform day after tomorrow. We'll be going through Kubernetes basics day after tomorrow. Tomorrow, we'll walk you through, or we'll be having a hands-on experience for you to how to create the Docker images, how to spin those Docker images into the containers on your VMs only, on your own virtual machines hosted on your laptops. We will be doing like that. So for that reason, what I want from you people today is to install Docker on your Ubuntu VMs, which are hosted on your laptops. Understood? Whatsoever Ubuntu VMs being hosted on your laptop, you need to install Docker on them. I'm giving you a brief tutorial of how to install Docker on Ubuntu. Okay. People have got the link in the chat box itself.
Yes, sir.
So this is how you can install the Docker engine onto your virtual machines. Okay. So this is one part. Today's task is just to install Docker on your Ubuntu VM. Second task is to create free account on Docker Hub. People know what Docker Hub is now? It is a repository. Like GitHub, there is a Docker Hub. And you people need to have a free account created onto the Docker Hub before tomorrow's class, so that we can flawlessly walk you through the hands-on experience of Docker image creation, and then we will be having your Docker your images pushed onto your Docker Hub registry linked to your account, and then we will be pulling those images onto other people's Docker engines or other people's virtual machines, so that how distribution of the Docker images can happen. This will be a sort of testing for you. Okay. Understood? Any doubts till now? Anyone?
No, sir.
So what I'll be doing is I'm just okay. This is hub.docker.com. Here you people can have your free account registered. Like I have my account. You people always can have your account. And in this particular, you will be having the following.
So there's also Docker desktop application for Windows in the same portal
Yes.
I saw. So,
Yes, Docker does. Yes, yes. What?
so we are doing it on Linux, or we can also do it on Windows, like on a host OS.
Very easy will be if you will be going on with the Linux, you can say pathway, because operating Docker engine on Linux is very easy. Performing the operations by using the command line interface on Ubuntu or any other Linux distribution, that will be preferable for you, because as engineers, whenever you will be going on to into the client's environment or in any such sort of environment, you need to be well familiar with CLI, command line interface. And that is basically possible when you will be doing that particular stuff on the terminals of Linux operating system or Ubuntu. Docker engine on Docker desktop is a bit different, and that again comes with a level of complexities. What I can say is Docker desktop must be consuming the Linux environment being spun up on the Windows. So that will be a bit complex. You need more troubleshooting to get the things hands. So apart from that, from the future perspective and from the, you can say, client's perspective also, you need to have a hands-on on the Linux environment. That is why I am basically more bending you towards using the Docker engine or Docker installation on Ubuntu or Linux VM itself, so that you can get familiar with the commands and other terminology. Okay. Got it? Fine. So what I was talking of is Docker Hub. You people need to create a Docker Hub account over where you can always push your Docker images. Okay. Tomorrow we'll be discussing of this Docker Hub, Docker images, and the process of creation of Docker images using Docker files. I'll be walking you through what are the various Docker commands after you will be having the Docker engine on your VMs and Docker Hub account. And I'll be walking you through from various sort of Docker files written. So what will be responsible for creating Docker images, and then how to use those Docker images to spin up a container inside the environment, made with VM or on a platform. Okay, tomorrow we'll be discussing on to, or that tomorrow's session will be more of a hands-on session. So tasks for tomorrow, please write down, and I want all the things what is being taught to you people today in the similar fashion. The previous days you had put up on all those things onto the chat box. Today also I expect the same. Write down all the things you have heard today onto the chat box. And another thing is, write what are the tasks being given to you. One is to install Docker engine. Another one is to have account of Docker Hub created. Then tomorrow we'll be walking you through these Docker files and all the process of creation. That will be more of hands-on. Day after tomorrow, we'll be walking you through the Rancher or Kubernetes. This is a Kubernetes platform being spun up upon in our lab environments. We'll be walking you through these things day after tomorrow. How these things work on. And if time will permit, tomorrow we can always discuss of what germ servers or what are the various ways how we can consume the environment. Okay. This, you people have always, I had told you that like this. You have heard of long for various. We had always heard of Apache Kafka, what Cassandra is, what is Apache Spark. You people have heard of these terminologies. Now, in VM environment, it will be a difficult or tedious task to deploy these clusters, to have these clusters spun up upon so that we can consume the computing power of these clusters. But in Kubernetes, as I had told you earlier itself, that it is a orchestration engine. It do the things in autonomous manner. So it will be very simple to deploy all these things onto a working Kubernetes cluster by just only clicking. Like if I'll be consuming this chart to configure or to deploy Apache Kafka full you can say stack or a cluster, we can always do this from here. We can always do have a Spark cluster running, consuming this chart on Kubernetes. So Rancher is one of the distribution. We will be talking of this week. Walk you through. Yeah, tomorrow. Okay. Understood? Any doubt related to today's class?
No, sir.
So the people who have not completed the HA proxy task can always complete that HA proxy task today, configuration of all those things, like I had told you in the very start of the session. Others, all people need to have the two tasks. What is Docker engine installed on the VMs before tomorrow's class so that we can always walk you through the processes, and Docker registry, like Docker Hub
Okay, sir.
account creation. Tomorrow we'll be going through that. And please don't forget to write down onto the chat box that what we had studied or what various topics we had gone through today. Fine. So if any issue, you can always reach out to me. And I believe all the things are done from my side. If you have any of the doubts, you can always talk, or else we can wind up on today's session. Fine.
Okay, sir.
Fine. So fine. You can
And
always
sir, in
wind up.
hypervisors, there was this
Yes.
type 1 hypervisor, and do you suggest we go through the type 2 and type 3? Or are there any?
Like normally in industry itself, now you will be dealing with type 1 hypervisors.
Okay, sir.
Basically, in industry, in learning environment or in training purposes, for training purposes, you are using type 2 hypervisors or for your own personal testing. In actual industry environment, you will be dealing with the rack mount servers. Lower those rack mount servers will be type 1 hypervisors. May it be Hyper-V by Windows, if there will be Windows environment, or VMware's ESXi. You will be dealing with vSphere to support multiple hypervisors. You will be dealing with all these stuff basically. So most important, you can say, focus of yours should be towards type 1 hypervisors. Learning how type 1 hypervisor works. So that is how you will be able to troubleshoot the problems in the future itself. Okay. Fine. Any other query?
And so Dockers in general, they are supported by Azure and AWS, Oracle, or is it something specific? I guess they're all supported interlinked.
Yes, yes. Docker, we can always spin it up on any environment, like on any cloud environment, on-premise, or anywhere. Because to install Docker onto the systems, we will be having repositories. We'll be having apt repositories for Ubuntu. We'll be having Yum repositories for Docker. For other Fedora, we have
Yes, sir.
all.
CentOS based.
That particular Docker scenario is supported by all the cloud service providers because underlying most of the you can say containerization environment played a larger role by the Docker itself. But nowadays, the open source system is being more advocated of, and that is Containerd, CRIO, CRIO. So they are strong candidates.
Yes,
What
sir.
are being
I
used
asked
by
it because this Docker service is being provided by Docker Hub. So it must be
Hmm.
an industry in itself, a company or a provider in
Yes,
itself.
Docker is a company itself. So for the reason of open source, or you can say for the
Yes,
fear
sir.
of open sourcing, I think the industry is always is already going towards the container D and other open source environments like Cryo and
Okay,
all.
sir.
So this is how the things are spinning up in the like Kubernetes was previously being supported by Docker, or Kubernetes uses Docker as a container engine for its platform, and that was mandatory. But a year ago only, they have changed the actual dependency from the Docker to the container D. So now, in the future advancements of Kubernetes or future releases
Yes,
of
sir.
Kubernetes, they are nowhere using Docker as the underlying container engine. They are using Cryo and container D only because of their open source nature.
Okay, sir.
So this is how the industry is shifting.
All right.
Any other query? Anybody? Fine. Thank you for now. We will be joining tomorrow, and before tomorrow's class, I expect you people to have Docker Engine installed onto your VMs, Linux VMs, as well as the Docker Hub account created. And the third thing is, like others are writing, please write down today's what we have covered. Fine. Thank you all. Thank you very
Thank
much.
you so much, sir.
Yeah.